Go.
Gas stoichiometry? Well, what is it?
Ano? Oh, hindi ko alam. Hindi ko napansin.
Magandang araw and good day. I'm Kuya Martin and we'll tackle gas stoichiometry. It may come in different forms and variables. Now we're located in an isolated stoichiometry environment known as Phase 7. Creatures here are very rare and there are only 5 in fact. These 5 creatures will help us in determining gas stoichiometry. Gas stoichiometry? Well, what is it?
Gas stoichiometry is the quantitative relationship or ratio between reactants and products in a chemical reaction with reactions that produce gases. So yeah, not the lived, unique experiences of gases, but definitely what their outputs are when put in a certain reaction.
Now, let's start to find those 5 creatures. Now I'm walking around Phase 7 to find the most dangerous of the bunch. The most silent as well. His name is Carl. Although I'm not scared, he only puts pressure on those who wrong him. Speaking of, I'm well versed in zoology to conclude that his mood is very swell. Seems like he's had a great afternoon so far. Now this one, this girl, this good girl. I've encountered her once before and she's definitely the nicest one. And her name's Dorothy, and I'll let you on in a little secret. She has a superpower that can turn her into something like gas that takes up space. How's that for a volume? And look, I found her. I'm lucky enough to find her in its physical face. Now this is starting to get weird. The next species, you all probably know him. Experts told me he lives in the Bikini Bottom. Now he lives here in Phase 7 without water. Weird, right? Nonetheless, he's a very chill starfish. And yes, that's right. It's fat egg. He represents mass because, well, he's big. You can't find your yellow friend, huh? Oh great, I think we can manage in my laboratory. Does everyone know who is going to be our next species? No? Well, it's an owl, and he spent years studying in university. His name is Oscar. Surprised me too back then. Last year he got his BS Chemistry, and now he's writing for his master's degree. Oscar is a henny. There you are. Do you have a paper to complete? Well, everyone, here's Oscar. And he's writing a study about counting of moles. Can you believe that? For the last creature, he used to live underwater too, but now he's stuck here in the Philippines. His full name? Octavian Octopus Grant McKinley Julian Miller Westinghouse IV. Yeah, I'm pretty tired, and I think he's making the environment warmer. You old cephalopod. I know he's usually smiling, but I think maybe it's not the best day for him. Now, let's go back to Phase 7 laboratory, my laboratory, where we assess the 5 stoichio species there. Here.
We all understand what STP means. It's standard temperature and pressure, meaning a 273 Kelvin environment for Octavian, a 1 atmospheric mass from Charles, and Dorothy can take up 22.4 liters of empty space. There are other units, like Celsius for temperature, milliliters for volume, and millimeters of mercury and torr for pressure. Now, these other units also come in the form of various deer species, but they're in Phase 8, outside of my jurisdiction. If we get Celsius, just add 273. If we get milliliters, just divide by 1000. And if we get millimeters of mercury or torr, just divide by 760. Simple as that. For gas stoichiometry, you may potentially need the ideal gas law, formulated by John Ideal Gas. Its formula is PV is equals to nRT.
If Charles is missing, P is equals to nRT over V. And if Dorothy is missing, I get sad. Joke. Then V is equals to nRT over T. And if Oscar is missing, N is equals to PV over RT. And if Octavian is missing, P is equals to PV over NR. And Patrick will only get lost if it comes to the actual stoichiometry. So, how do you actually do it?
There will be a lot, and I mean a lot of fractions and division involved. So, here's my advice. Be patient, and let's practice that now with a few sets of problems. For problem number 1, solid magnesium nitride reacts with excess liquid water to produce ammonia gas and solid magnesium hydroxide. If 4,700 milliliters of ammonia gas was collected at 27 Celsius at a pressure of 1.6 atmospheric pressure, how many grams of magnesium nitride was consumed in the reaction? Magnesium has 24.3 grams per mole, nitrogen has 14 grams per mole, hydrogen has 1.01 grams per mole, and oxygen has 16 grams per mole. Don't forget to balance the equation. It's clear that the species missing here is Patrick. Where can that starfish be? Only then can we convert the volume of ammonia gas to moles of ammonia using the ideal gas law. The answer will be 0.305 moles of ammonia gas. Then, convert moles of ammonia gas to mass of magnesium nitride. With this, we get the final answer. 15.4 grams of magnesium nitride was produced after the reaction of the compound with water. For the next problem, what if the worst case scenario happens? Not an accelerated climate crisis that threatens to wipe out humanity, but what if Dorothy the dog was missing? If 15.0 grams of potassium chlorate is decomposed, how many liters of oxygen gas measured at STP will be produced? Potassium has 39.1 grams per mole, chlorine has 35.45 grams per mole, and oxygen has 16 grams per mole. Balance the equation. Now, convert the mass of potassium chlorate to moles of oxygen gas. The answer will be 0.612 moles of oxygen gas. We can now use the ideal gas law and substitute the appropriate values.
In conclusion, 13.7 liters of oxygen gas were produced after the decomposition of 15.0 grams of potassium chlorate at STP. Exhausting? Well, those are only 5 problems. And in real life, there are a lot more of them.
Did you know, if the reactants and products are at the same conditions of temperature and pressure, then mole ratios of gases are also volume ratios. That's why, if for example, we have 3 moles of hydrogen gas and 1 mole of nitrogen gas reacting with one another to produce 2 moles of ammonia, we can use those factors in determining the respective volumes. As a result, there are 67.2 liters of hydrogen gas and 22.4 liters of nitrogen gas, resulting in 44.8 liters of ammonia.
And we're almost done. Let's just take a listen to pre-recorded Kuya Martin's video to conclude our informal session.
Pre-recorded Martin here, gas stoichiometry involves a lot of solving and identifying which variables are missing to derive the appropriate formula and finding the correct answer. When in doubt, always believe in the stoichiometry process. First, get the amount of the reactant either in mass or volume. Then, get the moles of the reactant. With this, we can proceed in getting the moles of the product. And similarly, we can obtain the amount of the product also either in mass or volume. One can also use the ideal gas law, using Charles, Dorothy, Patrick, Oscar, and Octavian as the tools in identifying the right steps towards the problem. A very complicated process indeed.
And that's it. As usual, I hope you've learned a lot. And thanks to Charles, Dorothy, Patrick, Oscar, and Octavian. And without them, I wouldn't derive formulas for the ideal gas law. It's been a fun ride, but as always, I'm Kuya Martin. Next time around, it will be Ate Jonah who will take the reins of Lakbay-Kapnayan. And it will be somewhere more populated. Any guesses? Well, that's end our full measures. Lakbay-Kapnayan.